Welcome back, 8th grade. So we're going to start talking about what a function, like we've talked about graphing, we've talked about linear versus nonlinear, we've talked about, we haven't talked about domain, that's what we're getting ready to go into, but we've talked about function rules. Now we're going to talk about like how do I know that something is a function. So how am I going to decide that this is a function? So key vocabulary, right? A relation is any set of ordered pairs. So anything I can create into an ordered pair, that's a relation. So we could take a graph and create a set of ordered pairs, that becomes a relation. But if it's just a set of ordered pairs, I have no like function, I don't know if it's a function or not, we call that a relation. Our domain is our input values. Remember, our input are our x values. So our domain would be our x values. Our range is our output. When I plug in my input, what do I get? So that probably should sound a lot like our independent and dependent variables, right? Output is what we get after we put in something. So the domain is our x values or our independent variable, and our range is our output, our y value, or otherwise known as our dependent variable. We're going to talk about what a vertical line test is. That's going to be in our next video. And then function notation. And so that's to write a rule. Like if we're writing our rules in function notation, we're going to use a symbol like this f of x in place of y. So instead of writing y equals and then our answer, we're going to write function of x. Now, why do we do that? The reason for that is when you get into science papers or statistical papers, anything that is writing formulas for math, or maybe even in a sales report, and they're trying to show you the different graphs, and they're talking about the different functions of those sales. They need to be able, we can't name them all y equals, we want to give them basically each their own function name. So like f of x or g of x or h of x, or for sales, s of x. Just kind of giving it something that later on, instead of having to write the entire equation later in the report or the paper, we can just refer to it by its function notation. That's the reason for it. You may be like, Mrs. Cartwright, I'm never going to have to use that. You may not have to write it, but there may come a time, some of you, where you may have to understand and read it and understand that that's what that means, is that there's an equation somewhere on some table that you would refer back to know what that equation is. All right, so key concept, we just need to remember that a function is the pair of one output with exactly one input. So for every x, there is exactly one y. Okay? Although that reads slightly off us. But for every x, we have exactly one y. The easy way for me to remember that is that x cannot cheat on y. X cannot have multiple y partners. So our first example, identify the domain and range of each relation represented, and then represent with a mapping diagram. And then after we do that, we're going to decide whether the relation is a function. So first, domain. Those are our x values. So we're just going to go through. It is always x comma y, right? So my domain is my x values. I've got -2, 0, 4, 5, and my range are my y values. So I have 0.5, 2.5, 6.5, and 2.5. So since I have 2.5, I'm only going to write it once instead of writing it twice. So I'm going to get rid of that one. Now, to create a mapping, and a mapping is like we're mapping from one to the other. It's more of a visual. And we can use like mappings for categorical things too, like football players and their height, or football players and their weight, or football players and the position they play, that type of thing. But in this case, we're doing numbers. So our domain is our first, we make them into bubbles. So I put these in numerical order. So -2, 0, 4, 5, and then I draw like a rounded rectangular just to say that that is my domain. And then I'm going to do the same thing over here, again putting it in numerical order, so from least to greatest, 0.5, 2.5, and 6.5. And again, my rounded rectangle. When you see these in the books or on Math Excel, it's going to be more oval, like Mrs. Cartwright is not the best at drawing those on her little keypad, so I draw rounded rectangles. From here, it is exactly what it sounds. I just map my -2 mapped to 0.5. So I'm going to draw an arrow from -2 to 0.5. From 0 to 2.5, I'm going to draw an arrow. From 4 to 6.5, I'm going to draw an arrow. And then from 5 to 2.5, oops, I was going to 6.5, not 2.5. From 5 to 2.5, I draw an arrow. Now, so that I identified the domain, I identified the range. I made a mapping diagram. Here's my mapping diagram. So now the question is this relation a function? And so all I have to do is I've got to look at my x values. Do any of them have 2 arrows going over to a y value? No. Each x value, my -2, my 0, my 4, my 5, they each have their own arrow. So this is a function because x does not cheat on y, so this is a yes. And the reason is for every x, there's exactly one y. And you may say, but Mrs. Cartwright, 2 of them went to 2.5. Well, it's a double standard. X can't cheat on y, but y can have multiple partners. So we can have 2 x values have the same y value, and it's okay. All right. Next. And again, when I write my domain, I just write them as I see them, and then when I write my bubble, I put them in order. So we have 6, a 4, we already have the 6 written, and a 5. And then my range, my y values, I've got 5, 3, 4, and 8. So those are my y values. So now when I go to map it, I'm going to put these in order. So I have 4, 5, 6, and my rounded rectangular boxy thing. And then in order 3, 4, 5, 8. Notice that I never repeat my domain values, so or my range values. Over here I didn't put the 2.5 twice, I didn't put it twice in my box. Over here I'm not writing the 6 twice in my mapping or up here in my domain. I just write it once. And then I just map. So from 6 to 5, 6 to 5, 4 to 3, 6 to 4, and 5 to 8. Now, when I go to ask myself, is this relation a function? It's not. Notice that there are 2 arrows going from the 6. So this is no. And the reason is because 6 has 2 y values. Oops. ES, not just S. All right. So if you are just given a list of points, you don't want to see your x value repeated. That would be a first clue, is seeing the x value repeated. If you are looking at a mapping, you don't want 2 arrows. So the one thing to remember when working, basically all these videos I'm about ready to go through with you, if x repeats, it's not a function. That's what it comes down to when we look at tables, when we look at or coordinate points like these right here, when we look at mappings, anything we look at and ask, is it a function? If x repeats, the answer is no. In the next video, we're going to talk about the vertical line test and how to tell from a graph if the relation is a function. See you there.